Right, again, we're looking for common factors. Okay, so if we look at this expression, we've got the not A. Next door to it, we've got another thing with not A in it. Okay, so what I'm going to do, and it's got B and C, they all look common. So the first three terms are common. So I'm going to just grab hold of those, and I'm going to say not A and B and C. And then in the brackets, I've got D and D or not D. That simplifies. D or not D is always going to be 1. Okay, so that simplifies to 1. So we end up with that expression for that entire half, straight away. Do the same on this side. Let's look for the commons. So in this case, it's poor old D that's going again, but it looks of it, because we've got ABC and we've got ABC. So we're going to pull out ABC. What I'll do is I'll do this again in math notation, just to show you how actually math notation is simpler to do, I think, for the majority of these. And in the brackets, we're going to have D or not D, which is exactly what we ended up with on the last one. So we know that reduces to that. So we end up with an expression that looks like this. Again, we can look for common factors. Okay, so we look at it, oh, we've got B and C in both of those, so let's take B and C out. So I haven't done anything complicated in this one. There's no like, absorption rule, which is the only one that's hard to remember. So we've ended up with not A or A. So we've done the same thing 3 times, which tends to be what happens when you're doing these Boolean algebras. So again, that's going to reduce to 1, which leaves us with B and C, which is what we were looking for. Okay, so that actually, even though the initial expression looked really complex, the actual reduction was straightforward. But it was the common factor that helped. The distributive rule, as it's called. If I didn't do that, or I didn't know about the distributive rule, then I'm stuck. From a maths perspective, it is this common factoring that you're generally doing in order to do reduction in maths as well. Alright, so it is the same process. We've got these fancy names for everything. There are like 10 names for all the different rules. And there are more rules than this, but they're all just a mixture of those ones that you've got. Right, I'm going to write this in maths notation and just do the same process. Right, so I've got not A, B, C, D. I'm going to write in super lazy maths notation as well. I'm not even going to put the dots. Right, that's it written in maths notation. Alright, it makes it actually, because you haven't got these horrible not symbols and the and symbols, it makes it easier to spot the common stuff. So you can look at that and you can say, right, okay, so it's not A, B, C, and then it is D. And this one, A, B, C, D. It looks nicer. I'm a mathsy person, so to me it looks nicer. The only time when the logic for writing out the algebra is nicer is when we do De Morgan's law, which we'll get onto. Alright, but I'm not going to talk about that yet. So you can see straight away that that does easily reduce, and then you can spot the common factors. It's just easier to see, I think, personally. So if you ever get a question like this and they've written it in algebraic notation, and you think, you know what, they're going to make me do Boolean algebra, I prefer to write that. Rewrite it and work through it. They've got to accept your answer. You know, at the end you might go, oh, I'll write it back in logic notation, but you can do your working in whatever you want. It's up to you. So again, you can see straight away that you can spot the common factors dead easy. And because you're not putting all these ands and ors all the time, it just looks right, and there's less mistakes you can make, I think. You know, you're not going to go, oh God, which was and, which was or. Because you just don't make that mistake when you're doing it in maths. And then you go straight away, you go, that's 1. BC times 1 is BC, isn't it? And then we go, all right, let's please the exam board and write and. There's your point. But I would do that. Just to stick it to them and say, yeah, it's equivalent. Which is what the 3 lines means. Okay? Right. I'll put them up on